Hi, everyone. Welcome to Kitchen Chemistry with me, Mr. Pancic. What we are going to do today at home, we're going to make some pancakes.
Oh, good morning. You're just in time for breakfast. And you know, there's nothing I like more for breakfast than a nice stack of pancakes with maple syrup and some butter just dripping off it. And you know, the best pancakes are made from scratch. So I've got all my ingredients here. And you can see here I've got my eggs, sugar, flour, milk, everything you need. There's more than one recipe, but we always end up with wondering about these two guys, baking soda and baking powder. Baking soda, baking powder. What's the difference? I want you to find out by doing some pancake experimentation.
Let's start off with baking soda. You've seen this. Baking soda is essentially sodium bicarbonate. Now, you guys know what sodium bicarbonate is because you know that sodium is Na and the bicarbonate radical is HCO3. So sodium bicarbonate is NaHCO3. And this is a base. We haven't really talked about acids and bases yet. Right now, what we need to know is that a base is going to react with an acid. And an acid is anything that dissociates in water and puts H plus ions into solution. A proton actually is all it is because hydrogen atoms are simply a proton and an electron. And without that electron, it's just a proton. So acids put H plus into a solution and bases react with that H plus. What happens when we bake pancakes is not quite putting hydrochloric acid in, but this allows us to see what happens a little easier. So if we add an acid to a base, they both disassociate in water, and the chlorine ion and the sodium ion both are free. And if they're free to move about, they combine and basically make sodium chloride. Well, that's great. Now that leaves this hydrogen over here. Well, this hydrogen is going to react with this hydrogen, and in a very interesting case, this radical is going to break apart. And you're going to have this hydrogen, that hydrogen, and an oxygen from the CO3 coming together to form H2O, water. So let's put that in our equation as well. What's left? One carbon and two oxygens, and that, my friends, is the key. Carbon dioxide as a gas. Now, when we bake something, we want those air bubbles in there. We want it to be light and fluffy.
So baking soda is sodium bicarbonate, and that means it will react with an acid. I'm going to show that with this vinegar. Vinegar is a great acid to use. We've got it in the kitchen. So let's take a look at what happens when we add these two together. All right, so let's put some vinegar in this glass. And you want to do this over the sink. Try this at home, but remember to do it in the sink, otherwise you'll make a mess and your parents will not be happy. Take a spoonful of sodium bicarbonate, add it, and carbon dioxide is released. That carbon dioxide bubbles in the pancakes is what gives the pancakes its rise. That's what makes a nice fluffy pancake. But to get that rise, you need something acidic.
Baking powder is that baking soda, but it also has acid in it that can create those bubbles even if your batter is not acidic. What we used to do years ago was use something called cream of tartar. You might have cream of tartar in your kitchen cabinet. It is actually the crystals left in the bottom of wine barrels after they've made wine and drained it all out. When they cleaned up the barrels, they found this white stuff in the bottom. And that stuff is actually quite acidic, but not as strong flavored as something like vinegar. So original single-acting baking powder was nothing more than cream of tartar and sodium bicarbonate. Today, though, we have what we see as double-acting baking powder. And that has a couple more ingredients. It contains, of course, the sodium bicarbonate. It contains also sodium aluminum sulfate, usually, and then usually monocalcium phosphate. And one more thing, cornstarch. Why does it have all these things? Well, the sodium bicarbonate, is the base that is going to react with the acids, and sodium aluminum sulfate and monocalcium phosphate are the acids. Now, one of them will react immediately, start bubbling. The other one will only kick in at 140 degrees, which means that when you start baking your pancakes or cooking them, boom, you're going to get another punch of fizz coming in there, another reaction that makes some more carbon dioxide to fluff up your pancakes. We need a little cornstarch to absorb some moisture. If we have an acid and a base together, the moisture from the air around it could start them reacting in the jar itself. And that wouldn't be very good for baking. So we have 4 things are in there. And what that should tell you is that if you have baking powder, you only need 1/4 to 1/3 the amount of baking soda to get the same rise as the amount of baking powder you use. Because, of course, the baking powder contains 3 to 4 times as much stuff in that same teaspoon. Why do you combine the wet ingredients to the dry ingredients only at the end of your preparation, just before you're going to bake? Well, now you see, as soon as you add the wet ingredients and the dry ingredients, your baking soda is going to start the reaction at that point. And you want to start cooking when all those bubbles can be trapped in your batter. You don't want to let that batter sit too long and have all the fizz go out of it. With the double-acting baking powder, you get a little extra. So if you let it sit too long, but when you heat it, you're still going to get some of that fizz. One of the things to remember, though, is that if you have a batter that uses something acidic, like, let's say, yogurt or buttermilk or honey, lemon juice, all these types of things, then some of the acids that are in the baking powder won't react, and it'll give you a sort of a sour taste to what you're cooking. On the other hand, too much soda can give you a sort of metallic taste if it doesn't all react. So you want a nice balance. Let's look at experiment part 1. What you're going to need for this is a measuring cup, some teaspoons, 6 clear cups, some water, vinegar, juice, and a timer. What I want you to do is this. Take those 6 cups, set them up like this, and in these 2, add some water, about a 1/4 cup of water. In these 2, add about a 1/4 cup of vinegar. In these 2, add a 1/4 cup of juice. Now, get someone to help you out from your family and close your eyes. Tell them to put baking powder in one set and baking soda in the other set. You don't know which one is which, but maybe you can tell from the reaction that you observe. To reiterate, fill 2 clear cups with 1/4 cup of cool water, 2 of them with 1/4 cup of vinegar, and 2 of them with 1/4 cup of juice. So you could have apple juice, orange juice. Those are fine. When you close your eyes, ask your family member to add 1 teaspoon of baking soda to one set and baking powder to the other. Now, open your eyes and start the timer. Finish timing when all the little bubbles stop rising to the surface. Record your answers. So some are going to fizz out pretty quick. Write those times down. Some are going to take a little longer, and some are going to continue to fizz. Since you're all starting the timer at the same time, you'll have a nice set of data about how long that reaction occurred for. And record your answers on the Google Doc. Were you able to tell which set was baking powder and which was baking soda? Tell me how you could tell. What did you use to come to your conclusion? Now, let's make some pancakes.
So you can add your dry ingredients together. Get your wet ingredients together, beat up those eggs. Whisk them up. But the thing you don't do right yet is add these guys, either of them. We're going to make a set of batter. Going to see what it's like without any baking soda or baking powder. Do a set with baking soda and a set with baking powder, and you'll see how we do that nice and easy in a minute. Alright, add the wet ingredients to the dry ingredients, and you've got a nice batter. So now that we've got our batter, so let's see to check if our griddle is hot enough, and if the water beads up, oh, that's pretty good. Make 1 pancake or 2 pancakes with this batter, with no baking soda and no baking powder in it. Cook them up and try them. What are your observations? How do they taste? How do they seem? Write it down in the accompanying page that goes with this video. Next step, take your batter and split it between 2 bowls. Now most recipes call for 1 tablespoon of baking powder. So we're going to put half a tablespoon of baking powder into 1/2 of our recipe, and we're going to put 1/4 of that of baking soda in the other. So baking soda in one, baking powder in the other. Okay, so I'm going to measure out 1½ teaspoons, which is half a tablespoon of baking powder, and I'm going to put it in this glass that has a little bit of warm water in it. And you can see the first action happening here. Remember, it's double acting baking powder. So the first action is going to occur when it mixes, and the second action, or the second release of carbon dioxide, will happen when it cooks, when heat is applied. Now with baking soda, we only need 1/4 of the amount because we don't have any of the acidifying agents in here or the cornstarch. So we're doing the same thing. Let's stir it up, make sure it dissolves. And you can see there's no fizzing because water is not acidic. So we're going to add it to our batter and see if there's enough acid in our batter. Alright, now let's try a little bit of each on the griddle. Make some pancakes, some with baking powder, some with baking soda. Write down what you think is going to happen. Cook them up, eat them, and write down what your observations are. This is a scientific experiment. Try to keep everything exactly the same except for baking soda, baking powder, and then our control, which is nothing. I can't wait to see what you guys come up with. Bye for now.